Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Would you like to learn, enjoy, and understand the beauty of basic engineering and scientific mathematics? That possibly it's a question you've been asking yourself for many years, but you have never found the right answer for that question. How are you, everybody who is watching this program? I would like to take this opportunity to welcome all the national and international ordinary diploma students or other students of other levels of grade 12, of different categories who can find that these contents are relevant and are fitting to the demand to their process or their journey or to your journey of thought of learning. So my name is Olenjolai, Moko TAYAI single. Simply you can call me Olenjolai. I thank God by His own grace He has given me a gift of teaching. Teaching is me and I am teaching. Simply how teaching has been built in me by God's grace is just like swimming has been swimming it has been built in the fishes. A fish always swim. So a fish is swimming and swimming is a fish. So Olenjolai is teaching, teaching is Olenjolai. God built the teaching in me. I have nothing else to boast myself. All the glory and all the praise be given to my sovereign God. So I'm a Tanzanian and this is our national flag. I would like to welcome you into a beautiful country where that you can enjoy the presence of God. And today I have a good news to every viewer of this program, to those permanent or to those regular permanent ordinary diploma students, and even to the new students worldwide. I have a good news. So get prepared to receive, digest, apply the good news that God has prepared and put in me for you. So I would like to take this opportunity firstly to welcome you into our fantastic playground, which is called Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. Simultaneously, I would like to welcome you into one of our official YouTube channel that called Online Diploma Polyinstitute of Tanzania in square bracket Olenjolai. I would like to remind you oftenly and several times about the vision that we have. What vision do we have? That's the question that you are asking yourself. Well, so we have an assignment to teach, train, incubate, mentor, and lead some ordinary diploma students on how they can extract knowledge, understanding, and wisdom from the classroom instructions in fundamental courses or modules, or in fundamental, even in the core courses or modules, and combine the extract means that the output with the knowledge, understanding, and wisdom that you are going to teach all our ordinary diploma students to extract it from the Word of God written in the Holy Bible, in order to solve real life problems. So our visions has mainly 4 parts that will change you radically. The first part will teach you to extract knowledge, understanding, and wisdom from the classroom education, whether formally or informal. The second part will teach you that to extract knowledge, understanding, and wisdom from the Word of God, whether you are learning the Word of God in church, maybe online, or maybe somewhere else, or in other playgrounds, or in different seminars, in different areas. But here we'll be teaching you what it has been written in the Holy Bible. And then the third part, how can we combine it? And the fourth part, how we can solve real life problems by using the combinations of the 2 knowledges, the combinations of the 2 wisdom, combinations of the 2 understanding. Wonderful. You can be, I know that this is kind of, this vision is kind of complicated in your mind and even in your belief. That is completely true. You are right. The complications you're experiencing, even myself in my own life, when I received this vision as the founder, or as a founder, as the instrument in founding this program, real, and even as God is instrument on solving real life problems, I didn't believe what God was saying in me. I thought it is completely impossible to combine the two knowledges, wisdoms, and understanding and solve real life problems. But myself, I'm a good example. I'm a prototype. Right now, I'm solving a national and international problem that are problems that faced by ordinary diploma students in their journey of learning engineering, different engineering programs and different scientific programs by God's grace. So I'm solving a real life problems. You are real life. The problems you're experiencing is not the examination problem. You're experiencing a real life problems that faced by people, not faced by the exam questions in the exam. Wonderful. So that is what. So the main objective of OLENJOLAM, Online Diploma Polytechnic Institute of Tanzania (Olenjolai) is to teach you how you have to think differently and how you can take classroom instructions in order to solve real life problems, because that's the main objective of education, right? That's what you have to remember every time and every day. And then you can ask yourself, you're asking yourself, is this teacher going to teach me what I fail to understand in engineering mathematics? The answer is yes. But if and only if the concept is within the curriculum and the syllabus, being the syllabus of ordinary diploma students, ordinary diploma level, right? I'm going to teach you. I'm going to simplify. I'll be using different methodologies on teaching and make all my sessions to be enjoyable and entertainment rather than confusion and discouragement. So we replace every kind, and we are going completely to destroy the belief that has been developing in the mind of many mathematicians in Tanzania that hesabu ni ugonjwa wa taifa. Will be reversing it. Means in English, mathematics is a national disease of Tanzania. That is completely true. That is completely false. Mathematics is an excellent solution of solving real life problems in Tanzania. That's what you have to replace with. Okay, I'd like to spend a few minutes just to take you, to navigate you on how you can register yourself permanently, because I think that you've been convinced, isn't it? Okay, so you have to follow these 7 steps for 2 main specific objectives. The first one, first of all, to get, or how can you get into the right school or into the place where we provide our contents online. But the second objective, how can you register yourself permanently in OLENJOLAM. And then the third specific objective of how you can access our content without too much hassles in a very systematic and excellent way. So the first step, if you don't have an email address, then we ask you to create it in the Google, whether it can be a Yahoo email or a Gmail. And again, we ask you that use your password and username of the email that you have. If you have one, use it to sign in YouTube. And then the third step, we ask you to search OLENJOLAM. Don't search OLENJOLAM because it's not there. What is in YouTube is this channel name, Online Diploma POLYINSTIT of Tanzania, in square bracket OLENJOLAI. OLENJOLAM is abbreviations of Online Diploma POLYINSTIT of Tanzania, POLYINSTIT of Tanzania, in square bracket OLENJOLAI. So in short, we call it OLENJOLAM. It's just the Dar es Salaam Institute of Technology. In short, we call it DIT. Wonderful. When you search it, you'll see around buttons, and then the side on the right hand side, you'll see that Online Diploma Polytechnic Institute of Tanzania, in square bracket OLENJOLAI. You'll see the number of videos that we have already published, which is more than 75. Then you see the number of subscribers. Then we ask you to click the round button. Remember that the round button should have a national flag. This we call it, it's the OLENJOLAM poster, welcoming poster. Whenever you go in any institutions, college or university, you'll find the welcoming poster or the identity or the poster, the identity poster. It means that the poster that identifies the institutions, college or university. This is what identifies us it's a national. We are teaching national level, not institution level, or college level, or university level. We are teaching this to the all national and international ordinary diploma student. Once you click, you'll see the horizontal top toolbar that's written home, videos, playlist, channel, and about. We'll come back later there. You'll see again a trailer video. Then look the buttons which has been written subscribe. Click these buttons once and then still change into subscribe. Once you click this button, the icon of the bell will appear. Click this icon of the bell, you'll see three options. We ask you to choose the options of all. From there, you have already registered yourself permanently. Why did you register yourself? First of all, in order to get to receive the notification from the YouTube whenever we add a new video. We have a vision to record more than 300 videos of basic and engineering scientific, basic engineering scientific mathematics. So we'll make sure that we upload at least one video in a day. So you have to visit regularly our online diploma Polytechnic Institute of Tanzania in square bracket Olenjolai for you to be updated and receive good news. Okay, so thank you very much for subscribing, and then you will find that your subscriptions is not for nothing. Then, so from there, the rest of the two steps is actually that giving you access or giving you knowledge on how you can access our contents without too much hassle. If you click this button or this way playlist, then find the playlist has been written to Numerical method. There you'll find the collections of all the lectures. All the lectures. This is we are done with lecture 00, we are done with lecture 1, we are done with lecture 2. This is lecture 3. Okay, lecture 3. Okay, so that's the number of the lecture. So in this playlist of Numerical method, you'll find collections of all the lectures from the first lecture to the last lecture. Again, we ask you that to click the icons of share to share video link to other ordinary diploma students or ordinary diploma parents via the social media, example Facebook, WhatsApp, Instagram. You can share this video link through Telegram, through Twitter, through email, through TikTok, so that millions of ordinary diploma students of present and future generation will have or will benefit on this fantastic program. Well, let me just explain briefly that what I've written there, the headlines. Let us go to the headlines. Welcome into Departments of Basic Engineering and Scientific Mathematics. In this department, we are teaching you more than 6 modules or courses. We are going to teach you a module of course called the algebra. We are going to teach you a module called the trigonometry, vectors, and complex number for NTA level 4. We're going to teach you a module called the differentiation integration, and we are going to teach you the module called the probability and statistics. That is for NTA level 5 or second year ordinary diploma. We're going to teach you a module called the conics and the differential equation, and we're going to teach you a module called the numerical method and series. And this is what we are going to teach you for NTA level 6, which is third year ordinary diploma student. So welcome into the course or into our modules that are called numerical method and series according to the NACTE syllabus and curriculum. This contents we dedicate to third year ordinary or D, this abbreviation, this is stands for ordinary diploma in engineering or ordinary diploma in science. NTA level 6, National Technical Award level 6 are provided by NACTE. This is chapter 1 called numerical method. We are in lecture 3 called the approximating root of a function by Newton-Raphson method. Ladies and gentlemen, myself, I'm ready to teach you what we are supposed to learn today and what God has prepared for you in order to enjoy the beauty of basic engineering and scientific mathematics. So this session, the overview of this session of this lecture 3, I'm going to teach you about problem solving by using the Newton-Raphson method. And we say that if you refer let us begin with quick review of lecture 2. Quick review of lecture 2. what we taught you in lecture 2 actually, first of all, we did the correction of the meaning iteration. Iteration, very important term in what in numerical method. What the means of iterations mean that we define, we give a definition. Say iteration is a repeated applications of a function or process in which the output of each state is used as input for the next iteration. Output of each state, and today we are going to do an example. The output of first state will be the input of the second stage. The output of the second stage will be the input of the third stage. That's what we call the first iteration, second iteration, third iteration, fourth iteration, fifth iteration, etc., etc. Then we taught you about the one of the iterative method that's called Newton-Raphson method. Okay, if you do remember, Newton is the name of the great ancient mathematician, and also Raphson is the name of another mathematicians. Together they have explained about how you can deal with numerical method. Okay, so Newton-Raphson method, what is it? And then so we find out two conditions of what? Of Newton-Raphson method. Then next, I taught you how it means that the graph of what? It means graph of what? Of Newton-Raphson method, how we can draw, okay, the method graphically. And then we taught you derivation. Derivation of what? Derivation of the formula of what? Of Newton-Raphson method. Newton-Raphson method. And then, you remember that. Say xn plus 1 is the final formula, is equal to what? Is equal to xn minus ffxn of what? Over first derivative of ffxn. But we didn't do any example. I then explained how we use iteration. So ladies and gentlemen, in today's session, we'll be focusing just the repetition. Recall the last concept that we taught you in lecture 2 that's called applications of what? Applications of Newton-Raphson method. Right? Applications of Newton-Raphson method. Okay? Applications of Newton-Raphson method. Then I told you that in the application of Newton-Raphson method, there are 3 applications of Newton-Raphson method. Okay? So, and then we wrote a sentence. In numerical analysis, there are 3 applications of Newton-Raphson method. The first one is the one that we are going to start today, approximating what? Approximating root of what? Of a function. Root of a function. Okay? Root of a function. So to approximate what? Approximating root of what? Of a function. So we can approximate the root of a function if the initial case is given and also if the function is differentiable. Right? Then the second applications, Newton-Raphson method is used to what? To find what? Reciprocal. Find reciprocal of what? Of a number. Find reciprocal of a number. Then the third application, Newton-Raphson method, is used to find what? This method also is used to find the nth root. The nth root of what? Of a number. So the nth root of a number. So these are the 3 applications of Newton-Raphson method that we have to teach our ordinary diploma students. But the good news also, we have another school that we call TANZANIA Online Advanced Secondary School in square bracket OLENJOLAIM, where we are teaching the same topic called numerical method to the Form 6 advanced secondary students. And we are also teaching them these 3 applications. So it's just like what we are teaching right now in ordinary diploma, NK level 6 or third year. Also, your friends, your classmates, your ordinary secondary school classmate, they are learning this concept in the topic called numerical methods as one of the topic in Form 6 for those who are studying mathematics, for those who are doing PCM, PGM, PMC, and even EGM students. So stay tuned. So ladies and gentlemen, let us go into the sport directly. I have mentioned different reference books and reference materials that will be used effectively on learning numerical methods and series, and I would like to use one of them right now in order to excite you and in order to prove. So we had example 1, which we left at the homework. So ladies and gentlemen, be ready right now to receive example 2 of numerical method, of Newton-Raphson method. And this example, you have to refer one of the tutorial sheet offered to ordinary diploma students at the Dar es Salaam Institute of Technology in Tanzania. And when you have this tutorial sheet, just check question number 11. Let me write the question state like this one. Graphically show the Newton, and this is the question which has been asked in so many past papers of numerical method. And so before this module, it has been called the numerical method, series, and complex number, or numerical method, complex number, and series. But there is change of the syllabus at Dar es Salaam Institute of Technology as one of the reference institutions that I'm using the syllabus. Graphically show the Newton-Raphson graphically show the Newton-Raphson method for approximation to the root. For approximation to the root. The root is given by xn plus 1 is equal to xn minus ffxn over f dash of xn. That's the question. My dear student, you can pause this video and list these 7 stages for you to register permanently in online diploma Polytechnic Institute of Tanzania square bracket OLENJOLAI, so you can enjoy our content that we are providing free of charge. Remember that registration, there's no any registration fee. In most physical institutions or colleges or universities, there is a registration fee that you have to pay as ordinary diploma student. The good news, there is no any registration fee in our institution. That's wonderful. God has already paid your registration fee. That's the answer of that question if you're asking. But why there is no registration fee? This is my Thanksgiving freewheeling. When I'm doing this program, I'm offering my freewheeling Thanksgiving to God, who has given me his gift and anointing on teaching the beauty of mathematics. So here's the question. So let us read the questions again. Graphically show the Newton-Raphson method for approximation to the root is given by this formula. So the answer is, or the solution of this question, you have to draw the graph, you have to follow all the steps that I taught you. So solution for this one, for this graph, you can solve. Now, solution for these questions, which is example 2, refer what we taught you in lecture 2 or 40. Lecture 2, that titled as what? Newton. So if you didn't check or didn't watch, you have to take that advantage right now. just to go into our YouTube channel, Online Diploma POLYINSTIT of Tanzania. Remember, these are the abbreviations of the two words, Polytechnic Institute. So these are the combinations of the two, combination and the abbreviations of the two words, Polytechnic Institute. So it's called the Newton-Raphson method. So just look a video like that one. Okay, so that's the answer for that question. Should not waste while you have a digital technology. The video is there, the revisions is the same that you have to show, and you have to make sure that you should be able to answer this question. So ladies and gentlemen, let us go to example 3. Right. Example 3. If you have any question, don't hesitate to ask that question. Don't hesitate to ask your question through the comment section of this video. Okay, we have example 3, and then refer. These are the common questions worldwide. Every ordinary diploma students has to understand these questions, or can meet with these questions worldwide. So refer tutorial sheet. Tutorial sheet of what? Tutorial sheet of numerical methods and series. Numerical methods and series, or series and complex number. That's the name of the module those years when this sheet has been created by the teachers who have been teaching mathematics. So refer the tutorial sheet and then check question 35. When you refer it, then we find this question and we are going to solve it right now. Starting with x is equal to 2. Calculate. Do you enjoy the beauty of basic engineering and scientific mathematics? Calculate an approximation to a root. Calculate an approximation to a root of the function. The root of the function f of x is equal to x squared minus 2 twice x minus 1, correcting to 3 decimal places using Newton-Raphson method. Using Newton-Raphson method. Use for iterations. Use for iterations. That's the question, ladies and gentlemen. You can pause the video and try to solve it yourself. Because we are implementing active learning technique. Active learning technique. So implement the active learning technique of what? Active learning technique where students can pause a video and try to solve a question before we solve it together, or before you check our solution and follow along. So you can pause a video and try it on the rough paper, and then you come back and check whether you got the right answer, your solutions is right or wrong. And don't be disappointed because you got or you did some mistakes in your try. I learn through mistakes in my daily life. So even these questions, when I met with them first time, when I was trying myself, I was doing mistakes. But I learned from those mistakes. Don't worry to learn from mistakes. Don't like to do mistakes, but worry, but dislike it to do mistake without learning something. Right? That's the key note where that I want to present to you. So ladies and gentlemen, okay, I believe that you have tried yourself. Let us solve together and do correction. Or as a student, they say that, sir, this is the first example, you have never showed us. If you've understood lecture 0, lecture 1, lecture 2, then you can go far as well as you can. But because this is the first example, let me open your eyes. Let me give them confidence. Then example 4, you'll try firstly, before we solve together. Example 5, you'll try yourself. Example 6, you'll try yourself. And then later on, at the end of this lecture 3, I'll give you the homework. Okay, starting with x is equal to 2. Calculate an approximation to a root of the function f of x is equal to x squared minus 2x minus 1, corrected to 3 decimal places using Newton-Raphson method and use 4 iterations. Why it has been recommended to use Newton-Raphson method? You can solve this question by using the method called regular false. You can solve these questions by using bisection method. So that's why it has been recommended that you have to use the Newton-Raphson method. But what are the two informations which are very important? The initial guess of independent variable x and the function. That's what you have to take consideration of. So we are going to follow a number of steps. We are going to follow a number of steps as one of the unique teaching technique that have been given by God to teach my student. The first step, we ask you to identify what? Identify the given function. The given function and the initial value. Identify the given function and initial value. Right? Of what? Of x. These are very important information. What the given function? The given function is f of x is equal to what? Is equal to x squared. You should have your scientific calculator. In case you don't have it, you may order it in our online diploma Polytechnic library. Right? So x squared minus twice x minus 1. Right? So this is the function that we have. And then the initial value, which this we call xn, right? This is just we call it x naught because the initial value is equal to 2. Okay? Afterward, we say that we are still in first step. Find the first derivative of the function f of x. So this is the first derivative, we call it first derivative f of x dash. This is equal to d dx of f of x. They have the same meaning, but we prefer to use this one as well as you see it in the Newton-Raphson method. So to find this one, we say that we are looking for f dash of x. So then we have to differentiate the given function with respect to x, and the given function is x squared minus twice x minus 1. So to differentiate this part, we have to use what? Power rule. Power rule, power rule, power rule. You can go further for the lovers of mathematics, and you can just separate or integrate each part of this function. Each term can differentiate the first term minus what? Can differentiate what? The second term, and then you can differentiate what? The third term, which is 1. So we say that f dash of x, if you differentiate this one by using power rule, 2 becomes the coefficient, then you have x in power 2 minus 1, then 2 is constant, so it will get out of the differentiation. Then here we have d dx of x power 1, so here we have times 1, then you have x power 1 minus 1, then minus, if you differentiate any constant, the answer is 0. Then we say that ffx dash. So that's why we taught you differentiation and integration in your second year, because we knew that we cannot teach you Newton-Raphson method without the knowledge of differentiation. 2 times 1 is 2, x power 1 minus 1 is x power 0, x power 0 is 1, so negative 2 times 1 times 1, the answer is negative 2. So this is our derivative function. This is called the derivative function of x. Very important. So the next step, ladies and gentlemen, I believe that you're enjoying the beauty. You're enjoying the beauty of numerical method. Tell me in the comment section, please. Tell me in the comment section, tell me in the comment section, tell me in the comment section whether you enjoy numerical method or not. Whether you understand what we are teaching you or not. Tell us in the comment section. Give us feedback in the comment section. Say, sir, thank you, I've understood you. Or sir, excuse me, I didn't understand this part. Ask your questions, interact with me in the comment sections of this video, please. Okay. So then we go to the second step. Technicians, okay? Technicians in engineering and science, we are going to the second step. The second step, we say that we have to recall what the formula, the general formula of what? Of Newton-Raphson method. I told you in lecture 2. What did you say? You say that x of n plus 1 is equal to xn minus what? ffxn over what? Over f dash of xn. Don't get confused with that n as a subscript of that function. Don't get confused with this one. So, ladies and gentlemen, after recording this formula, we have all the important information for the first iteration. Then we go for the third steady state. So steady state, we say that find the root for the first or find the root. So the steady state, we have to find the root of what? Of ffx for what? For first iteration. First iteration. How? So the first iteration, the value of n is equal to 0. So substitute 0 in n, in the substitute n. So it will be 0 plus 1 is 1. So here on the left hand side you have x1 is equal to x what? X is 0 minus what? ffx is 0 divided by what? F dash of what? Of x is 0. Right? Okay? So this is our new equation. Okay? Our new equation. So we may call this one equation 1. So it can be 5 and equation 2. So we know x naught. We don't know fx naught. We don't know fx1. So we say that in order to solve the problem, we say that we have to find out the ffx naught and the f dash of x naught. How? We remember the given function. ffx naught, this is equal to, what is x naught? X naught it is 2. Given. X naught it is what? It is 2. For ff2 is equal to the given function, which is x squared. So we have 2 squared minus what? Twice times 2 minus 1. So 2 squared is 4. Minus what? 2 times 2 it is 4. Then minus 1. So ladies and gentlemen, ffx naught is equal to negative 1, because 4 minus 4 is what? It's 0. So negative 1. Then we have to find what? F dash of what? X naught. From what? From the first derivative function, which is what? 2x minus 2. It is 2x minus 2. So in positions of x, let us replace 2 as initial value. That's x naught. Okay? X naught. So then minus what? Minus 2. So 2 times 2 it is 4 minus 2, the answer is 2. Right? So if that the case, it means that f dash of x naught is equal to what? Is equal to 2. Suppose these are the steady function and this one is the fourth linear function. So you go to what in the first step. Tell your neighbor that you're enjoying the beauty of Newton-Raphson method. The first step, we say that substitute equation 3 and the equation 4 in what? In equation 2 above. Okay? In case you find that I'm writing quickly, remember that the number of iterations, 4 iterations. So you have first iteration, you have second iteration, you have third iteration, and fourth iteration. So it's a kind of the long question, but that's what you have to do as excellent technician. So x1 is equal to x naught, which is 2 minus, what is the f of x naught? F of x naught, it is equation 3, it's what? It's negative 1. Divided by what? F of x naught dash, which is what? Is 2. So ladies and gentlemen, negative times negative, it's positive. So this will make it 2 plus what? A half. And the response is 2.5. That is our x1. So remember that the concept of iteration, that the output of the first state become the input of the second state. Right? So we say that we go for the first state. The first state you can also write differently, a little differently. Perform what? Thirdly, let us perform what? Perform second iteration. Let us perform second iteration. In this second iteration, say n is equal to 1. So, perform the second iteration, we have to recall the Newton-Raphson formula, which is xn plus 1. So 1 plus 1 is x2. Then here we have n, so we have x1 minus what? Minus f of x1 divided by f dash of what? Of x1. Right? So this will make equation what? Equation 5. Equation 5. So because this will make equation 5, then ladies and gentlemen, we say that that's wonderful. So because it's wonderful, we say again, let us find what? F of x1 and what? F dash of what? Of x1. How do we find? We have to recall the f of x function. It's x squared minus twice x minus 1. So it means that if you are looking f of x1, this is equal to f of what is x1? 2.5. So to find f of 2.5, it means you have to take 2.5 and then insert in the given function. Okay, minus what? Minus 1. So simply this will make what? 2.5, that's equivalent to 5 over 2. So it will be 25 over 4. Then here we have what? We have 5 minus 5, then minus 1. So it will be 25 over 4. So we say that f of 2.25, that's equal to 25 over 4. So it will be 60.25. So 60.25 minus 5 remain 0.2. So remember that here this is equal to 60.25 minus 6. So the response is 0.25, which is equivalent to 1 over 4. That is f of x1. So f of x1 is equal to 0.25. So this is equation 6. Then let us find f of x1 dash. So x1 is 2.5 multiplied by 2 minus 2. So this will make it 5 over 2 times 2, it is 5 minus 2, the answer is equal to 3. So f of x1 dash is equal to 3. So this will make equation 7. This is the style of solving. So even now, once we finish the second iteration, you can pause the video and then check for the next iteration. Okay? So we go for the fifth step, ladies and gentlemen. Fifth step, we say that substitute equation what? Question 6. Question 6 and 7 in what? In equation 5. How? What's question 5? Question 5, we have x2. What's x1? 2.5 minus what is what? What is the f of x1? It's 0.25. What is f? What is equation 7? 83. So simply, this will make what? So it is 5 over 2, and hence here we have what? 1 over 4 over 3. I want just to solve this. You may use calculator, but I want to try. I want to solve it easily without using scientific calculator. So here we have to divide this one. So we have 5 over 2. Then here 3 over 1. So you're going to have what? 4 over 3. Isn't it? No. So it means if we swap, because 3 over 1, so it will be, yeah, it will be here. We have 1 over 4 times 1 over 3. So this is x2 is equal to 5 over 2 minus what? 1 over 12. So the LCM is 12. 12 over this is 6. 6 times 5 is 30. 30 minus 1. I would like to welcome you into our online Diploma Polytechnic Library, where you can access original scientific calculator. This one costs only 55,000 Tanzania shillings, the original one. But there's number 2 of this Casio Function 981 MS, which you can order it with the price of 35,000 without the transport cost to your institution, to the place where you are, to any regions of Tanzania where you are. How can you order this scientific calculator and the other materials? Just send a message of your order to that telephone number 0759745331, and then we'll save you, and we'll be happy to equip you with relevant material. So here we have 29 over, so this will be 29 over 12, and in decimal places, because we've been asked to write these numbers in 3 decimal places, or just you can take 0.25 by using your scientific calculator, divided by 3, and then you have 2.5 minus the response. The answer is 2.41. So we have to express the response in 3 decimal places. So 660. So if you approximate, it's 2.417. What if we take 29, we divide with 12? We get the same response. Okay, so that is x2, and that is the output of the second iteration. So ladies and gentlemen, we have been recommended to do 4 iterations. So we have done 2 iterations. Let us do the other remaining iteration. So the third iteration. So So the third iteration, so you say that this will be the sixth state. So the sixth state, you can say that let us perform third iteration. What the value of n for third iteration? The value of n for third iteration is n is equal to 2. Recall equation 1. So in equation 1, x, then 2 plus 1 is x is 3, then it is what? x2 minus what? f of x2 divided by what? F dash of what? Of x2. So we know only x2. We don't know f of x2 and f dash of x2. So we say that let us find what? Let us find f of x2 and what? And the f dash of what? Of x2. Are you ready for that? You can try. You can pause the video and try to find f of x2 and f dash of x2 of the derivative function. Once you try, then you come back and you keep enjoying the beauty of what? Of numerical method. So from the given function, which is x squared minus 2x minus 1, so f of x2, what is x2? x2, we found it is 2.417. Substitute in the given function. So this is 2.417 square minus what? 2 times 2.417 minus 1. Again, there's an alternative way of finding this function. Just by using scientific calculator, you can create that function. So you press alpha and then find the letter x, then you square minus 2, press alpha, then x, then minus 1. And then you press the button split and calculate what the value of x there is 2.417. That's the simplest way. So what will you get? You get that the resulting is 0.788. So you have 2.417. The result is what? The result, you say that f of x2, this is equal to what? Is equal to 0.0, then you have what? 0.788. Remember, this is not the last response. Or in the scientific calculator, you see 7.889 times 10 to negative 3. Okay? Again, you have to find out f dash of x2. What is f dash of x2? F dash of 2.417. This is equal to what? So this is equal to our original function is 2. Our derivative function is 2 times 2.417. Then minus, is it minus 1 or minus 2? Minus 1, thank you. So minus 1. So for this one, we just multiply 2 times 2, 24,160,17, then minus 1. So it is 3. So you find that the f of x2 dash is equal to it. So remember that this is equation what? We ended in our numbering to equation 7. So this is equation 8. Okay? So this one will give us what? 3.834. This will make your equation 9. Equation 9. Then we go to the seventh step. The seventh step, ladies and gentlemen, we say that let us substitute what? Let us substitute equation 8, okay, and the equation 10 into what? So suppose that this is This is what you have to call equation A. I forgot. So this one, it's what? Equation 9. And this one is equation 10. So substitute equation 10 and 9 into equation 8. The equation 8 above. So if you substitute, we are looking for x3. What's x2? x2, it is 2.417 minus ffx dash, ffx2, which is question what? Which it is what? 0.07889 divided by what? F dash, which is 3.834. So we take 0.0. So if you lost your scientific calculator, don't panic. Just order the new one by sending the SMS. Don't call. So that telephone number 0759 74 53 31. So x3, this will make x3 to be 2.415 in 3 decimal places. So you find the value of the value of the root testing. It began with 2.5, then decreased it to 2.417. Right now, it has decreased him to 2.415. So, ladies and gentlemen, let me give you a quiz. Try to look or try to perform the first iteration. Perform it, try it. Right now, you are able to make it. Okay, so I believe, my dear student, that you've tried to solve this just to do the first iteration, because we've been limited to perform 4 iterations. So, how many iterations have we done? So we've done the first iteration, the second iteration, the third iteration, this is the third iteration. So I believe that you've tried the first iteration, and right now let us do correction to check whether you have got the right answer or you have made some mistakes, because I told you the great school in the world of engineering mathematics is learning from mistakes. So ladies and gentlemen, let us go into it. So remember that these are the output of the third iteration, be the input of the first iteration. So the eighth step, we ask you to perform what? To perform the fourth iteration. Perform the fourth iteration where the value of n is 3. So from a general formula in equation 1, xn, when n is equal to 3 plus 1 is x4 on left hand side. On right hand side we have xn, which is x subscript of 3, then minus what? Minus the function of xn, which will be f of x3, divided by derivative of a function when the value of x is f of x3. So this one was equation 10. We may call this one equation 11. Don't worry about the numbering. Equation 11 in mathematics, normal. And then we have a responsibility to find out. We have a responsibility as a technician, my dear technician, you have a responsibility to find out. We know the x3. Remember, x3 is the value we have as output of the third iteration. So find out. So let us find f of x dash of 3 and what? And f of x3. Wonderful. So by using what? The given function and the derivative function. I believe that you are enjoying competence-based learning system of numerical method? Isn't it? Please give me the feedback in the comment section. But again, another thing that we really appreciate to receive testimonies from our online students. Please write in the comment sections about your testimony. How did this program help you, and what can you say to other new students of present and future generation? Speak with other ordinary diploma students that in professions we call them technicians, present and future technicians of our own country, our own continent, and the world also needs millions of technicians right now. So the given function, we still remember that the given function is x squared minus what? The given function, we have original function. Yeah, the given function is what? It is x squared minus 2, no. Yeah, the given function is x squared minus 2x minus 1. So f of x3, this is equal to f of what? 2.415. This is equal to 2.415 square minus 2 times 2.415 minus 1. Okay, minus 1. So then we can just plug the numbers, the decimal numbers and whole numbers that we have there. 2.415, we square it, minus what? Twice times 2.415, then minus what? Minus 1. So the response is f of x3, this is equal to what? 2.2, is 2.225 exponent negative 3. You may leave or you may just change it into decimal, which will be 0.225. Remember that this is not a final answer. It's not the value of x. The value of x is the one that should be in 3 decimal places. But the value of the function for this for the certain initial value or for the certain value of x, it can have more than 3 decimal places. Bear that in your mind, because I heard in my heart there's a student who is saying, sir, because if, for example, we express this one in decimal places, you have 0.022, then 25. So straight if you write that as, because it's not the value of x, it's the value of the function. Then to find f dash of x3, we have to remember our derivative function, which is twice times the value of x3, which is 2.415 minus 1. No, minus 2. So you just have to use your scientific calculator, which I told you that in case you lost it, don't panic. You can order it in Audipital, and you can receive at any institution in Tanzania, including Unguja and Pemba. So it is 2.83. That is f of x3. So simply in terms of equation f of x3, this is equal to, okay, so you can put in a decimal place, 225. So this is equation 12. This is equation 12, because this one was equation 11. Then we have f dash of x3. This is equal to 2.83. This is equation 13. Wonderful. So, my dear students, once you reach this state, you have the values, you have to do substitution. So you have to do simple algebraic substitution. So the 9th step, you say that substitute equation 12 and equation 13 into equation 11. So when you do this substitution, you say that x4 is equal to what is the value of x3? It is 2.415 minus what? f of x3. What is the value of f of x3? It is 0.0022. 2225 divided by what the value for fx is 3 dash. Fx 3 dash, it is 2.83. Wonderful. So it means that you have 2.0, we have 0.002225 divided by the answer. Then you have 2.415 minus the response. So the answer is what? The answer is 2.414. So those are, mean that the first value of x was 2, the second value of x was 2.5, the third value of x, because the initial value was x is equal to 2, that's x naught, it is 2, x1 it is 2.5, x2 it is x2 it is what, 2.417, x3 it is 2.415, and the x4 is 2.414. So that will be the root of the given function. So the root of the given function will be the value of x4. But again, later on, I'll give you a problem where you are not limited in number of iteration. For this one, we've been limited that you should do at least, or should do 4 iterations. So there's a technique for you to recognize at which iterations should you end, because you should end, because iterations are infinitely. So you may go up to 11th iteration. So the iterations which can limit you, it's an iterations which gives the value, the root of the function closer or approximately equal to the root of the function given by the previous, means that the preceding iteration. What does it mean? For example, x naught is 2. Then you have x1 is 2.5. Then you have x2 is 2.417. Then you have x3, it is 2.415. Is it? Yes, 5. Then you have x4. If you compare these roots of the function, because we are approximating, and our responsibility as mathematicians to approximate, you find that there's a great distance. It means there's a great difference between x0 and x1. There's a great difference between x1 and x2, and there's a difference of 0.002 between x2 and x3, but there's a smallest difference between x3 and x4 of 0.001. For this fact, because these values are closer, x4 and x3 are close, it means are approximately equal. So it means that you have to end with the first iteration and you conclude that this is the right answer. Right? That is in case you are not given the number of iterations. I have prepared an example for you. So it means that we've been finding the root of the function. So the question asks us calculate an approximations to a root of the function that was. So it means that say in 3 decimal places. Therefore, the root of the function f of x is equal to x squared minus 2x minus 1 is 2.414 in 3 decimal places. That's the response. Check your rough work. Check your try. If you've been doing correctly from the point where I gave you a quiz, because remember that the first iterations is a quiz, so I gave you a quiz. So quiz, you can pause the video and do the first iterations yourself. But if you succeeded to get the right answer that x4 is equal to 2.414, congratulations, an excellent national and international technician. If you missed it somewhere, maybe you made some numerical computation, don't worry, don't get confused. Also, I appreciate you, And I believe that you are going to be a great mathematician and a great technician, right? So I appreciate. Congratulations for trying to solve a mathematical problems by using numerical methods of Newton-Raphson method. So, but learn from the mistake, check where you have made a mistake, and next time when you are trying the next question, don't do the same mistake. Well, if you have any question, don't hesitate to ask in the comment section here. On your left-hand side below, you'll see the comment section. Then put your comment there. Ask your questions. Give us feedback. Give us your testimony. How did you find that these contents are helpful for you? How did these contents rescue you from the supplementary exam? How did these contents restore your previous ordinary level, your previous love, your forsaken love of mathematics since you completed your O-level education? So tell us in the comment section, please. We read the comment section of every video, so that we may get the point, or we may learn from you, because you have to learn from me and I have to learn from you. Right now, later on, I will learn from you even through the videos, because I will give you another way or another platforms which we can interact. I can see you also, right? But at this moment, just in the comment sections, I want to see your thought through writing. Do it, please. Okay, so that's all about example 3. Ladies and gentlemen, I would like to welcome you in example 4. Example 4 of numerical method. Again, this question I took it as it means refer the tutorial sheet, the same tutorial sheet. Tutorial sheet of what? Of numerical method. And these questions have been taken from the basic engineering mathematics books, numerical methods of what? Numerical methods of DIT, Dar es Salaam Institute of Technology. And this, now we are going to solve question 18. Question 18. So let us read this question 18. The equation x is 3 x cubic minus what? Minus 3x squared minus 1 has one real root. Has one real root. Has one real root. Starting with x is equal to 3. Use 2 iteration. Use 2 iteration. Use 2 iteration. Iterations. Use 2 iterations of what? Of Newton's. Use 2 iterations of Newton's method to find what? To find an approximate. An approximate value for this root corrected to corrected to 3 decimal places. Correct to 3 decimal places. The equation x cubic minus 3x squared minus 1 has one real root. Starting with x is equal to 3, use 2 iterations of Newton's method to find an approximate value for this root correctly to 3 decimal places. That is example 4. And this question also, it has been asked me. So, in addition, refer, because we told you that the reference materials for you to learn and master numerical method for ordinary diploma engineering and scientific mathematics is you have to use past papers, you have to use tutorial sheet, you have to use basic engineering and scientific mathematics books. So you have to do a lot of things. So that's why I'm using this is the sheet for the tutorial. It has first page. So this tutorial sheet, it contains just first page, second page, and third page. It's a tutorial sheet that contains 45 questions. It contains 45 questions of 3 topics: numerical method, complex number, and series. So again, refer one of the DIT past paper. So refer DIT final exam of academic year 2015/16. Okay, or simply this at DIT we call it or D12. And this question, it was question number 1. So look, if you have this past paper, whether soft copy or hard copy, look question number 1, Roman C. It's the same question. So remember that this is referring about this question. Okay. So because it's one of the questions in the final exam, and this was what FE means final exam, or end of semester exam, end of second semester exam for NTA level 6 or third year of ordinary diploma in engineering programs or in science programs. Okay, so ladies and gentlemen, we say, okay, this is the question, let us solve it. Okay, let us enjoy the beauty of numerical, of Newton-Raphson method. We've been limited, we have to use what? The questions of that one says one root starting with x is equal to 3, use 2 iterations of Newton's method, either Newton's Raphson method or Newton's method to find an appropriate value for this correcting, for this root correctly to 3 decimal places. Solution. Okay, the first step, remember the first step for you to solve successful this question. Identify 2 conditions. Identify what? The value of initial value. The initial value of x has one root which it is what x naught is equal to 3. And then identify what and the given function. Given function. It can be the polynomial function, it can be exponential function, so it depends to the question. Okay, and given function. So what the given function here? So the given function, we let f of x is equal to what? It is x cubed minus what? Minus 3x squared minus 1. That's the question we have. So f of x is equal to x cubic minus 3x minus 1. So then that is, okay, so that's it's not here, that's all. Then we go for the second step. But the answer should be, the value of x should be in 3 decimal places. Second step, recall what? Newton's method. How does Newton-Raphson state? I taught you how to derive x of n plus 1. This is equal to xn minus what? Ffxn divided by what? F dash of xn. Okay? So if that's the case, right? So we go for the steady state. Steady state, we say that let us perform what? Perform the first iteration. How many iterations are we given? Or how many iterations should we do? Two, only two, only two, only two. So remember that we are training you by using the technique or the method that we call it active learning. So you can pause the video and try to do this question yourself, right? And then you come and check your solution. So for the first iteration, what the value of n? Value of n is equal to 0. So x on left hand side, you have x in subscript of 0 plus 1 is x1 is equal to what? X naught minus what? F x naught. What is x? X naught divided by what? F dash of 40 of x naught. Right? So if that's the case, we say again, we have a responsibility to find out f of x naught by using the given function and also, okay. Yeah. Okay, so I forgot a certain step to differentiate this function here, but don't worry. And what? And the f dash will differentiate in the next step, f dash of x naught. So there, ladies and gentlemen, we have our function f of x. We have to find first derivative. So we have differentiate both sides, left hand side and right hand side. The given function, which is x cubic minus 3x squared minus 1. So I told you that you have to differentiate each term of the polynomial of this cubic polynomial function. So differentiate this way. Then we have what? 3 is constant, so you take it out of the derivative sign. Then differentiate it. Here we have x squared, and then so you have minus dx of 1. So ladies and gentlemen, we have f of x dash. Then okay, so ladies and gentlemen, let us keep enjoying the business that you are doing of the beauty of basic engineering and scientific mathematics for the ordinary diploma, which we are preparing competence technicians who can solve real-life problems. So we are finding the first derivative of what? The first derivative of our function. The first derivative of the given function in example 4 at one of the tutorial questions. So if we differentiate x cubic, we get 3x squared, then minus. Then if we differentiate 3x squared, or differentiate x squared, we get 2x per 2 times a, or 2x. So if you multiply by 3, we get 6x. Alright? Then if we differentiate what? Negative 1. So negative 1, it's a constant. If you differentiate a constant, you get 0. So our derivative function, it is what? It is 3x squared minus 6x. In other words, you may say that this is 3x, then have x minus 2. Okay, so you can simplify like that. So for this case, because we had our general function here, so remember that always this is equation 1. And then again, where is our given function? So our given function, we have f of x there, and then we have that one. Yeah. So it means that these are the two functions which are very important, which we are going to use in each iteration. So it is what? It is 3x squared minus 6x. So ladies and gentlemen, remember that you have to do how many iterations? So the equation of that one says 1 roots, starting with this one, use 2 iterations. Use 2 iterations. of Newton's method to find an approximate value for this root, correct it to 3 decimal places. So we are still doing the first iteration. Do you enjoy the beauty of basic engineering and scientific mathematics? Do you enjoy the beauty of numerical methods as one of the very important method in engineering aspects or science aspects? So we have found the derivative of 40 of the given function and that ones. So we go for the first step. The first step, we have to find it. We have to find f of x naught, means because we are doing for the first iteration, and what? And f dash of 40 x naught. So f of x naught, where x naught is equal to what? We're being given is equal to 3. This is equal to what? We have our function. Our function is what? It's x cubic. So the value of x, it is what? It is 3. So then minus what? Minus 3. The value of x, it is 3 squared. Minus what? Minus 1. So this makes what? 3 by 3 times 3 power 3 is 27. Then minus what? 3 times 3 it is 9. Times 3 it is 27. Then minus 1. 27 minus 27, it's what? It's 0. Alright? Then minus 1. So it means that f of x naught is equal to 3 is equal to negative 1. So this makes what? This is our second function. Then we have to look for f dash of x naught, where x naught is equal to 3. What our derivative function? The 3x squared minus 3x minus 6, it's 6, the 6x, because if we differentiate this one to 6. So 3x squared minus 6x. So this makes what? 3, the initial value of x, it is what? The 3 squared, then minus 6, and 30, and 3. So, ladies and gentlemen, we say that f of 3, this is equal to 3 times 3 times 3 is 27. Then 6 times 3, it is 18. This makes what? So 17 minus 8, it's 9. So this makes 9. But 9 not positive. Okay? So it means that makes what? It makes 9. Okay, so this one is the question. So we are in the fifth step. So in the fifth step, we say that substitute equation what? Equation 2 and the equation 3 into equation 1. So where is that equation 1? Okay. So this is equation 2, excuse me, and this is equation 3, and this is equation 4. So substitute equation 3 and equation 4 into equation 2. What are we looking for on the left hand side? x1. What is x naught? It is 3. 3 minus. What is f of x naught? F of x naught, it's negative 1. Then what is f of x dash? F of x dash is 9. So this makes what? Negative is positive. So 3 plus 1 over 9. So 9 over 1. So the LCM is 9. And then you have what? 9 over 1 is 9 times 3 it is 27. 9 over 9 it's 1 times 1 it's 1. So it means that you have is equal to it. Okay, yeah. So it means that x1 is equal to 28 over 9. You may leave the response in fraction, or you can find it, because they are. So alternatively, you can say that alpha power 3 minus what? Minus 3 alpha power 2. And then minus 1. We are calculating for x is equal to 3. Response is negative 1. So negative 1 of what? Over 27 minus 18. 27 minus 18. Then we have 3 minus the answer. The answer is 28 over 9. In decimals, this is equal to 3.9. We've been asked you to express the response in what? To 3 decimal places. 1. So this is the output of, or the root of the function x cubic minus 3x squared minus 1 after performing the first iteration. So, ladies and gentlemen, you can pause the video and then try to perform the second iterations yourself. So we go, this is the 6th step. Perform second iteration, whereby n is equal to 1. So the formula itself, it's what it is, x2 is equal to x1, because the output of the first iteration will be the input of the second iteration. And hence we say that x1 minus what? f of x1 of what? f dash of what? Of x1. So this one will make equation 5. To make equation 5. To make equation 5. Okay. So if that's the equation 5, then we have to find what? Let us find f of x1 and what? f of x1 dash. Alright? So let us find the values of these two functions. So let us begin with f of x1. What the value of x1? We found it 3.11, and then x1 it's what? It's x cubic, right? Minus what? Minus 3, and then say what? X squared. So 3.11, then square, minus what? Minus 1. So if x1 is equal to 3.11, this is equal to what? You have 3.11 for 3 power 3. Then we have to subtract this what? 3 times what? 3.11. Close bracket, close again. No, square, then I close again, minus 1. So the response here is 0.076. 7429. And put in 5 decimal. Remember, this is not the value of x here, or it's not the root of the function. Okay? So to prove it, you can insert the function alpha x cubic minus 3 alpha x squared, then minus 1. You can insert the functions into a scientific calculator. Okay, so it is alpha x cubic minus 3 alpha x squared minus 1. Then you calculate for 3.11. So the response is 0.07429. Then we have to find out f dash of x1. This is equal to finding f dash of what? Of 3.11. And then our derivative function was what? 3x squared. And this x squared, its value of x squared of x, it's 3.11 square minus what? Minus 60, then 3.11. Okay? So then we say that what? F dash of 3.11. This is equal to what? So it's equal to 3.11 power 3. And then minus what? 60 times 3.11. So the response is 11.44. It's better to use high decimal place, so to get at least the accurate response. So then this we call it equation what? So this is equation 6 and this is equation 7. Right? So if that's the case, we go to what is the 7th step. Okay? The 7th step. So the 7th step, we say that substitute equation 4 and equation 7 into equation what? Into equation 5. Into equation 5 above. So when you substitute, we are looking for x2. x2 is equal to x1, which is 3.11 minus what? ffx1. Where is ffx1? ffx1, it's 0.074, then 29. Divided. F dash of x1, it's 11.443, then 26. This makes what? So this is 0.0. So use your scientific calculator. 7429 over 11.44326. Then you have 3.111 minus response. The 3.105 in 3 decimal places. So remember the question, we have been asking to find or estimate the root by performing only 2 iterations. So this is the second iteration, and the good news that there's a clause, means that this is the closest value of 3.11. So you have to end there. So therefore we say that the root of what? Of the function of x cubic minus what? Root of the function x cubic minus 3x squared minus 1 is what? Is 3.105. Are the response. Okay, so ladies and gentlemen, I believe that you've been enjoying this lecture. That's lecture 3, approximating the root of the function by using Newton-Raphson method. So you've been enjoying in the previous 3 examples. Right now, it's a time for me as your beloved teacher of basic engineering scientific mathematics to test your level of understanding. So in order to test your level of understanding, ladies and gentlemen, I will be leaving the homework at the end of every lecture. It can be at the end or in the midst of the lecture or at the beginnings of the lecture, because you know most students, they don't like homework. So once they hear the homework, they can quit the video. Don't do that, because this is for your own benefit. So this is homework. So we number the homework according to the number of lecture. This is homework 3, and then this is example. So this is example 5. It's a conceptual question. Conceptual question. There's a certain concept that I want you as my student to identify. It doesn't mean that it's difficult. I've spoken that concept orally, but I didn't write, and we didn't do a direct example of that of the concept that I want you to identify here. So the question states that use the Newton-Raphson method. Use the Newton-Raphson method. No, not method. Remember that to use the word method or formula are interchangeable. To find what? To find the root. Find the root near to of the function x cubed minus 3x minus 5 is equal to 0, correcting to decimal places. 2 decimal places. 2 decimal places. So use the Newton-Raphson method, or use the Newton-Raphson formula that is acceptable in mathematics to find the root near to of the function x cubic minus 3x minus 5 is equal to 0, corrected to 2 decimal places. Don't ask me some more questions, some more clarification, or don't ask me any clarifications of the questions. The questions is completing, and nothing is missing in this question. What is missing is what you have to use your entire comprehensions of the lecture 1, lecture 0, lecture 1, lecture 2, and lecture 3. Wonderful. Ladies and gentlemen, before I end this lecture 3, I have a good news I would like to share to all my present and future technicians in Tanzania, in Africa, in Asia, in America, in Australia, and even in America. However, at this moment, this good news will be taken into advantage only for ordinary diploma who studies. Only ordinary diploma students who are studying in Tanzania. So if you are studying if you are studying any ordinary diploma engineering or science program in Tanzania, in any institution of Tanzania, then you have to listen carefully the good news that I'm going to share with you. By God's grace, we thank that He has given us an idea to establish also online diploma polytechnic library, where we have books, or we'll be having books in the library, we'll be having materials, it means notes, we'll be having scientific calculators that are useful in learning mathematics, learning physics, learning chemistry for high school and even ordinary secondary school. So today we have two items which we like to present to you in order in order to have such good news, and you can take action, or you can put in actions as soon as possible, so that we can solve, or we can meet your demand that you have been struggling on how you can figure it out. So the first item, we have original scientific calculator number 1, which we call the Casio function 991 ms, and also we have number 2, Casio function 991 ms. So this is original scientific calculator. So this is number 1. This one, it costs more than 60,000 Tanzania shillings in the most local shop. But by God's grace, because God loves you so much, you can order this original scientific calculator with a gift of only 55,000 Tanzania shillings. Again, we have another items at the product. We have so many basic engineering mathematics books, and also we have some other extra basic engineering mathematics and basic scientific mathematics. One of the reference book that we recommend to all the 30-year ordinary diploma students, and especially when you want to learn in advance about numerical methods, and especially Newton-Raphson method, we recommend this book that called the Pure Mathematics 1 by J.K. Backhouse and S.P.T. Holdsworth. So make sure that you have this book. We can order with a very reasonable, just you can offer a gift of 30,000 Tanzania shillings. Remember that the price of this scientific calculator for number 1 is 55,000 Tanzania shillings without the transport cost. And the price for this Casio function 991 ms number 2, it is 35,000 Tanzania shillings. And there's no transport cost. Even this one, the gift of 30,000, it does not contain what a transport cost. The transport cost is exclusive in every price that I'm going to mention to you. Then I thank you for paying attention. You can ask yourself a question: how you can order now these materials that are found in the online diploma polytechnic library. That's a good question. At the top, at your right hand side, at the top of this video, you see there is a telephone number, a mobile number. It's 0759745331. This is my official registered telephone number that I've been using it for 5 years. You have to send an SMS of your order, and you have to mention your level, because we have 60 online schools, so we are saving thousands of people. So make sure that you introduce yourself briefly, whether if you're parents that you say have a kid who is doing diploma in engineering, maybe first year, second year, third or fourth year, or we can ask you those questions once you send your SMS and we make a call to you. And then so we just negotiate a business, and we accomplish the business so that you can have these materials. We want to equip you, and we can send this book in any institutions in Tanzania, or to any students in any institutions or college or university in Tanzania. So thank you very much for paying attention. Ladies and gentlemen, this is the end of lecture 3. But again, before I end lecture 3, thank you very much, my father who is near me. He reminded me something. The contents we are providing to you, the video, means the program, this program that we are providing to you, you would have paid a lot amount of money for you to get it. It's very worth the contents, everything that we are doing, the materials. We spent years to prepare the materials, to make a plan, to experimenting and practicing. So it's a worth program. But God is the founder and the sponsor, my God, and possibly it might be your God also, is the founder and the sponsor of this program. So he has given us an assignment to provide this content free, but he opened the doors for any student or parents or sponsor or even guardians who would like to offer him a free willing thanksgiving for what he is doing to you, or he is doing to your son or to your daughter through this program. And you may send your free link Thanksgiving of any amount, even of the 50 Tanzania shillings, maybe of 500 Tanzania shillings, through this, it means that is through this telephone number. And your free link Thanksgiving will be used to pay for the running cost of the entire programs, because we have a vision to record more than 300 and provide more than 300 videos that will be teaching ordinary diploma students, that we call them in brackets, the technicians, the beauty of basic engineering and scientific mathematics. So again, don't forget to subscribe if you didn't make it, or maybe if you didn't follow this lecture 3 from the beginning. Remember to subscribe, remember also to like, remember also to share this video to other millions ordinary diploma students. Again, remember that to read the descriptions below, click the buttons written show more for you to get more information about our other online schools. Possibly your young brother or your young sister or your son or your daughter in O-level or in A-level or in undergraduate engineering studies might get help, or maybe even also yourself, you want to know God, then you might learn different ways, or you might learn God's ways through our online schools. So, ladies and gentlemen, I thank God who have created me in His own image and likeness. I thank God who have given the opportunity to join me. I thank you also for consecrating, for listening, for asking questions, for giving me feedback in the comment section. I thank you also for asking me questions about this lecture. I thank you also because you are going to do the homework. I thank you in advance for everything that you plan to do. And may God help you to make sure that you do it. Please tell us in the comment section that you're enjoying these contents, from which institution, from which college, what program, what engineering programs are you doing? Are you doing maybe ordinary diploma in electronics and telecommunication? Or are you doing ordinary diploma in civil engineering? So tell us in the comment section, please, because we want to know how did we spread, or how this message is spread to solve mankind's problem. So may God bless you abundantly and keep you until we meet in the next session. Don't forget to do the homework and submit in the comment section so that other students can review your homework and can learn from the mistakes during the practice time before you go to answer the exam or the final exams, or you're going to solve a particular real life problem. So may God bless you. This is Olenjolai, a national teacher or a national teacher who teaches ordinary diploma students, and it's only by grace that also I'm a national international teacher of basic engineering and scientific mathematics. So may God bless you abundantly and keep you until we meet in the next session.
Africa.